Hi everyone, my name is Marvin M. Pocon, a Bachelor of Science in Computer Science student at the Northeastern Mindanao State University, Lianga campus. Now I am presenting my thesis entitled of IoT-based soil moisture and plant monitoring with automated irrigation for lettuce gardening. Background of the study. Traditional methods struggle to sustain precision agricultural conditions in lettuce farming. Lettuce crops have high sensitivity to hydration cycles. Inefficient moisture supply blocks cellular growth, while excessive watering leads to root decay and mold. By integrating multi-sensor arrays, capacitive moisture sensor, pH level, and ambient microclimate, this project creates a self-regulating growth setup. The addition of Edge computer vision camera module allows for rapid leaf anomaly identification using a machine learning algorithms. Problem statement and objectives. Unidentified gaps, resource waste, lack of dynamic irrigation triggers to lead critical overwatering or crop dehydration. Blind operations. No remote monitoring or telemetry tools existed for local farmers. Late detections. Manual visual crop assessment delay corrective action against foliage health issues. The specific objectives. First is the integrated framework development automated micro-irrigation system powered by the Raspberry. Vision diagnostics. Implement a robust ULO-V8 computer vision model to detect healthy and unhealthy crop states. 3 is the telemetry platform. Design a cloud dashboard for real-time telemetry access. Review of related literature. Smart Irrigation by Cotalona et al. 2024 and Niswar 2024 established that automated hydroponic frameworks with real-time feedback decrease manual operational cost while substantially maximizing lettuce crop yield and overall quality. Hydroponic Tech by Chowdhury et al. 2020 illustrated that dynamic parameters tracking, such as balanced nutrients and soil moisture levels, yields up to 30% to 50% higher profitability margins over standard field cultivation. 3 is the computer vision by Wang et al. 2024 proved that modern object detection neural networks achieve over 95 to 99% accuracy rates assessing health states and identifying disease in commercial hydroponic fields. Next is the IPO model, or the Input Process Output model, serves as the conceptual framework for the system, showing how data flows from the environment to physical automation and cloud interfaces. In the input, this stage involves the gathering real-time environmental data via a sensors array, like the soil moisture, humidity, and pH level. The processing stage is handled by the two microcontrollers, the Arduino Uno and the Raspberry Pi. The third is the output. The final stage delivers the system actions. This includes triggering the 5V water pump relay module, displaying image data localized by the 12IC LCD screen, updating remote or blink in the blink dashboard, and automated SMS alert. Next is the machine learning life cycle. Is a cyclical framework that guides a project from initial concept to a real-world deployment. It begins with defining the problem and collecting a raw data, which is clean, annotated during the data wrangling phase. This structured data is used to train an algorithm like ULO-V8 to recognize the patterns, after which the model accuracy is rigorously evaluated. Once performance metrics are verified, the finalized model is deployed into a live production environment like Raspberry Pi for continuing monitoring and real-time automation. Data preparation, or the data gathering. The data preparation is the phase where the raw assets are cleaned, organized, and transformed into high-quality datasets before being fed into the machine learning model. This involved collecting a 920 liters images or the datasets. After the data preparation or data gathering, we are using a RoboPro workflow, a platform that datasets of Lithos images was managed, annotated, and processed to a clearly label healthy and unhealthy leaf conditions. This structured data was then used to train the YOLO V8 object detection model. After that, the data wrangling is the process of cleaning, organizing, and transforming messy raw data into a neat and usable format. Think of it as preparation raw ingredients before cooking. You filter out of mistakes, handle missing information, and restructure the layout so it is ready for analysis. Because raw data is usually full of errors, this step is essential to ensure that your final reports or machine learning models are built on accurate, trustworthy information. Circuit diagram. The circuit diagram serves as the system technical blueprint, mapping out how the hardware components are interconnected across the two distinct microcontrollers to enable automated irrigation and monitoring. It illustrates the Arduino Uno hub, which is wired to the capacitive soil moisture, DHT11, temperature or humidity, pH, and ultrasonic water level sensors, alongside an 12 volts LCD for local readouts and relay module that safely triggers the 5 volts DC water pump. Simultaneously, the diagram maps out the independent Raspberry Pi hub, showing its direct connections to a USB camera module positioned above the crops to handle high-level processing and YOLO V8 computer vision tasks. The final product. In this stage, the final product is the fully functional dual-hub smart agricultural prototype or hydroponic that bridges physical automation with artificial intelligence for precision lettuce farming. In case of durable, weather-resistant structural frame and physical unit features a localized hydroponic or soil-based setup integrated with an Arduino Uno and the Raspberry Pi. This is the YOLO performance matrix. Over the 0.995 mean average precision mapped at 0.5. Precision target classification. The train network demonstrated outstanding accuracy and isolating lettuce states. The validation confusion matrix illustrates 457 correct healthy classification states and 463 correct unhealthy classification states, showing excellent true positive balance with minimal context clutter. Blink dashboard. The Blink dashboard serves as the system's remote control center, allowing farmers to monitor and manage their lettuce garden from anywhere through a mobile application or a web browser. It features an intuitive user interface populated with real-time data widgets that display live telemetry from the field, including soil moisture percentage, ambient temperature, humidity levels, pH level, and water level. Beyond visualization, the dashboard acts as an automated alert system, sending an instant push notifications or SMS updates directly to the user's phone by the Raspberry Pi detects an unhealthy lettuce crop. In this phase, to get this rating by conducting a survey to the local farmers and gardeners by the using of the pilot testing of the actual fully functional hydroponic system to show them how it works and how it is fully useful to their needs. After the pilot testing, I gave them a survey questionnaire by filling up the form. So you can see I see the usefulness has the main rating over 0.53 over 0.40 strongly agree. Ease of use has the 4.59 main rating over the 0.18 strongly agree. Ease of learning has the 4.68 over the 0.15 strongly also agree. The satisfaction has the 4.68 over 0.24 strongly agree. The total grand mean has 4.62 over 0.24 has strongly agreed. The summary and conclusions: high responsive hardware loops. The dynamic threshold loop using the Arduino Uno successfully automated the soil watering cycle adjusts immediately based on the soil moisture data to eliminate water waste. State-of-the-art diagnostics. The age-implemented ULO V8 and nanomole yielded the high diagnostic precision over the map at 0.5 to 0.995%. This proves the computer vision is highly dependable for effective lettuce foliage health tracking. Broad community acceptance. The usability grand mean rating of 4.62 shows the local agricultural communities find the system highly innovative, featuring low barrier to entry for daily farming work. So this is the end of my presentation. I would like to express my deepest gratitude to my advisor, Ryan Aguirre, and to all the faculty and staff of the Department of Computer Science. So this is the thank you and goodbye.